Okay, so now we're going to do these three problems. A rectangular one, a triangular one, and one that has an equation using integration. Okay, so let's start with the rectangular one. It's a different problem. W is 200 pounds, per foot, right? I forgot the unit there. And it's spread over 4 feet. So the force is equal to the integration of W dx. So that's the integration from 0 to 4 of 200 times dx, which equals 200x spread from 0 to 4. It comes out to be 800 pounds equals F. And now remember, in order to find that distance, the distance is going to be the moment over the force. And this I could calculate from integration. And this I could calculate from integration. And remember what the moment was? The moment is force times the distance. So it's integral of W x dx, which means it's from 0 to 4. W is 200, x dx, which comes out to be 200x squared over 2 spread from 0 to 4. So what's that? 4 squared is 16. 16 times that is 3,200. 3,200 divided by 2 would be 1,600?
Yep.
Okay, 1,600 pounds. Inch pounds, because we're looking at a moment. And then we know the distance is equal to the moment over the force, and the moment is 1,600 over 800, so it comes out to be 2 feet. Wait, we're dealing with feet. Sorry. Feet. So my X bar, usually, you probably have seen that before, that centroids they usually put a bar over the value. So does this make sense? If we were to go back to this and we made it a point load, let me do it in a different color. If we did a point load, and this is 4 feet long, I would know it's 200 times 4, and it would be 800 pounds. And the distance from the end would be half, because it's a triangle. And is that the same? Yeah, 800 pounds with a force, and the centroid is 2 feet. So now we just did a problem with integration that we really didn't need to do an integration, but we did it so we could practice. So let's do the next one. Well, W is 750, or rather the value here is 750. I'm sorry, it's not W, it's the value here. And the value here is 0. So what do we need to do? This W is really the equation of this line, right? Because here's my y-axis, and this is at 200. I need to find the equation of this. What is the equation? What is W equal to? So just to go back in the video, rather than me redoing it, remember before I said W is equal to 750, but that's incorrect. It is just the y value at this point that's 750, not W. So what's the equation of a line? Y is equal to mx plus b. So y is equal to, what's the slope of this? It's 750 divided by 4 times x plus b. What's the b? The y-intercept is 0. So y is equal to, what's this divided? 1, 3, 4 into 3 would be 5. 75. What's this number? 87.5. 187.5. X plus 0. So this is the equation of my line. So my equation is 187.5x. So now, let's do the force. Force is equal to the integration of W dx. It goes from 0 to 4. W is 187.5x dx, which means it's going to be equal to 187.5x squared over 2, spread from 0 to 4. And what does that value come out to be? Let's see, 187, it comes out to be 4,000 foot-pound. So this is what F is equal to. And then what is M? M is the integration of Wx dx, which equals 0 to 4, 187.
Foot-pounds for a force?
X.
Foot-pounds for a force?
Foot, thank you, just foot, just pound.
Just pound.
X. 187.5 x times x dx. So it comes out to be 187.5 x cubed over 3 from 0 to 4. And it comes out to be that was the moment value. I'm going to have to do this over. The force is 1,500. It's better when I have students in front of me, because then you guys could correct me when I make a mistake. So 187.5 x squared divided by 2 from 0 to 4 is 1,500. And the moment comes out to be 4,000. And this is foot-pound. So what is the centroid equal to? The moment divided by the force. So it's 4,000 divided by 1,500. And what's that value come out to be? 2 2/3 feet. So let's go back and do the math the way we did it before. So we know that the force is equal to 1/2 the base times the height. That's 2 times that, so the force turns out to be 1,500, of course. And the x bar is going to be, let's measure it from this end. Let's measure the x bar from this end, because we said it was 1/3 that way. So it's 2/3 of 4. And does that come out to, that's equal to 8/3, which equals 2 2/3 foot. So whenever we're given shapes that are rectangular or triangular, we don't have to do all this integration. But I want to show you how to do it so that you can actually check yourself. Because when we get to a problem like this one, where we're getting a shape and we're given an equation, we're going to have to do the integration because we don't know where the centroid is of that. Maybe you do. Maybe you remember the centroids of all shapes. But I don't. I only remember the triangles and the squares. Okay, so force is equal to integration of W dx, which equals the integration of 200x minus 25x squared dx, and we're going from 0 to 4. So the force is equal to 200x squared over 2 minus 25x cubed over 3, all spread from 0 to 4, and the force turns out to be 1,067 pounds. And then the moment is equal to the integration of Wx dx, which equals the integration from 0 to 4 of 200x minus 25x squared x dx. And it comes out to be 200, gotta distribute this x, right? So it's really 200x squared minus 25x cubed. So it's 200x cubed over 3 minus 25x4 over 4, all spread from 0 to 4. And the moment turns out to be 2,667 foot-pound. And then R, is this too low?
Do over the
Yeah.
side.
So x bar is equal to the moment over the force, 2,667 divided by 1,067, and the x bar turns out to be 2.5 feet. So let's make it this an equivalent system. And what kind of equivalent system? We're looking at a force location problem. We have a beam that's 4 feet long. It had a distributed load of this. We found that the force is 1067. And where should it be located? It should be located 2.5 over. And this is 1067 pounds. This is an equivalent system to this initial problem. Keep it on. So just to go back, when you're given a distributed load that is rectangular or triangular, you know where the centroid is. You do not need to do all the integration. But if you're given a shape that you don't know the centroid of, you have to do the integration. You have to find the force using integration. You have to find the moment, do it using integration, and then you solve for the centroid. The fact that the centroid came out to be such an even number, I'm guessing that we probably should have known where the centroid is of this. So I could go back in my notes and look at the different shapes. I'm curious now, because if it came out to be 2.5, I mean, 200x minus 25x squared, isn't that a parabola? Is that a parabola? So if I'm looking at a sheet, then I'll make a copy for you. There's also one in the textbook at the back of the book, but they don't have a parabola in there. Let's see, a parabola. Seeing if there's a parabola here. Quadratic. Yeah, a parabola. It winds up that the x centroid, well, I could show you this in class. We could cut out now.